Okay, hi viewers. This is M. Samahadri, lecturer in statistics. Today I am explaining one of the important theorem in probability. The theorem name is Bullish inequality. Bullish inequality is one of the important theorem in the semester examinations. Right? The statement of the theorem is first I am write the statement. So the statement of this theorem is if for n events a1 comma a2 and so on an comma we have the first concept is p of intersection I running from 1 to n ai is greater than or equal to summation I running from 1 to n p of ai minus of n minus 1. And the B statement is second statement P of union I running from 1 to n ai is less than or equal to summation I running from 1 to n P of ai. This is the statement of Bullish inequality. So for example, there are n events in a random experiment. The events are a1, a2 and so on n. We have the first concept is P of intersection I is running 1 to n a greater than or equal to summation pi minus n minus 1. The second one is P of union I running 1 to n a less than or equal to P of ei. Okay, so we shall prove this theorem. We shall prove this theorem by using principle of mathematical induction, correct? So we shall prove the inequality. We shall prove the inequality using the principle of mathematical induction. Principle of mathematical induction. So prove the inequality using the principle of mathematical induction. So what is the procedure for mathematical induction? There are 3 steps in this theorem. The first step is we have to prove that n is equal to 2, and second step is let us suppose that the theorem is true for n is equal to r, and third step the theorem is true for n is equal to r plus 1. There are 3 steps in this principle of mathematical induction. So now we have to follow the first step of the first theorem a concept. So first step is we have to prove that n equal to 2, not greater than or equal to 2, right? So there were 2 events. Okay, I'm taking 2 events. There is P of a1 union a2, right? So I'm taking addition theorem for n events. So I did the 2 events. Okay, so I'm taking addition theorem for probability for 2 events. What is the addition of events from? That is P of a1 plus P of a2 minus P of a1 intersection e8. It's very simple. This is the additional theorem for 2 events formula. P of a1 union a2 is equal to P of a1 plus P of a2 minus P of a1 intersection a2, which is always less than or equal to 1. So probability value always less than or equal to 1. But not greater than or equal to, not greater than 1 or less than or equal to 1, right? So this is P of A1 plus P of A2. Now P of A1 plus P of A2 is less than or equal to P of A1 intersection A2 plus 1, right? Plus 1. And now I want only P of A1 intersection A2, right? P of A1 intersection A2 is greater than or equal to P of A1 plus P of A2 minus 1, right? So this can be written as, that implies P of intersection I running from 1 to 2 AI is greater than or equal to summation I running from 1 to 2 P of AI minus of this is 2 minus 1 is written as 2 minus 1. 1 is written as 2 minus 1. Okay, so we have to observe the statement of the given statement. P of intersection I is equal 1 to 2 A greater than or equal to summation I running 1 to 2 P of A minus of 2 minus 1, right? Therefore the theorem is true for therefore the theorem is true for the theorem is true for the theorem is true for n equal to 2. Now the second step of this concept, let us suppose that let us suppose that the theorem is true for let us suppose that the theorem is true for n is equal to r, right? So the statement, so in the statement P of intersection I running from in the place of n, write r. Okay, r a I is greater than or equal to summation I running from 1 to r P of a I minus of r minus 1. This is equation number 1 and this is equation number 2, right? Next, third step of this theorem, the third step, we have to prove that we have to prove that the theorem is true for the theorem is true for n equal to r plus 1. The theorem is true for n is equal to r plus 1. Now consider P of intersection I running from 1 to r plus 1, that is important, r plus 1 is equal to, this can be also written as P of intersection I running from 1 to r a I intersection ar plus 1. Already you know that this concept in last videos. I am explained the last videos. That is equal to P of intersection I1 to r a intersection r plus 1, right? This is a1 and this is a2. P of a1 intersection a2 from 1. So what is the from 1? P of a1 intersection a2 is greater than or equal to P of a1 plus P of a2 minus 1. That's right. So this is P of a1 intersection a2 is equal to, this is greater than or equal to, which is greater than or equal to, right? It's simple, which is greater than or equal to P of a1. What is a1? Intersection I running from 1 to r a I plus P of a2. It means a r plus 1. What is that? Minus 1. So since from 1 from 1, right? P of a1 plus P of a2 minus 1, right? That is greater than or equal to, by using 2, what is the equation number 2? Let us suppose that the theorem is true for n is equal to r case. That is the equation number 2. Intersection I1 to r greater than or equal to ai. So observe that this is P of intersection I running from 1 to r ai. This is also P of intersection I running 1 to r ai, right? So in the place of write 2, okay? So that is summation I running from 1 to r P of ai, P of ai minus that minus minus r minus 1 plus P of ar plus 1 minus 1, right? This is P of intersection I on to r a expansion. So summation P of r I on to r P of a minus r minus 1 plus P of ar plus 1 minus 1, right? So this is already written as I running from 1 to, this is P of a 1 to r, the P of ar plus 1. So adding two terms, summation I running 1 to r plus 1. So P of ai, what is that? This is that minus of r minus 1 and plus 1, which is greater equal to summation I is equal to 1 to r plus 1 P of ai minus of r plus 1 minus 1. Observe that therefore P of intersection I is equal to 1 to r plus 1 ai is greater equal to summation I is equal to 1 to r plus 1 P of ai minus of r plus 1 minus 1, right? Hence the theorem is true for, therefore hence the theorem is true for n is equal to r plus 1. The theorem is true for n equal to r plus 1, right? So by using the principle of mathematical induction, the theorem is true for all positive degree values of n. This is the theorem first one statement proof, and second one means b bit, okay, right? B concept. So this theorem also prove that the using the principle of mathematical induction, okay? This principle by the principle of mathematical induction, okay? We shall prove this theorem, prove this also by the principle of mathematical induction. So mathematical induction, okay? The first step is we have to prove that theorem is true for equal to 2, okay, and equal to 2. So now I'm taking same position P of a1 union a2, right? P of a1 union a2 is equal to, what is that? P of a1 plus P of a2 minus P of A1 intersection A2. Okay, which is less than or equal to P of A1 plus P of A2, right? P of A1 plus P of A2. Observe the statement of the statement P of A1 plus P of A2 minus of P of A1 intersection A2. Subtract this term. This is P of A1 plus P of A2. This is only two terms adding. Okay, so usually this is the big value. So finally, therefore, P of A1 union A2 is less than or equal to P of A1 plus P of A2. This is equation number 1. And this is also be written as P of union I running from 1 to 2 AI is less than or equal to summation I running from 1 to 2 P of AI. Right? Hence, therefore, the theorem is true for n equal to 2 case. Right? Next one is let us suppose that let us suppose that the theorem is true for theorem the theorem is true for n equal to r. Therefore, P of union I running from 1 to r AI is less than or equal to summation I running from 1 to 2 P of AI. This is equation number 2, right? So now third step of this theorem, we have to prove that we have to prove that okay, the theorem is true for the theorem is true for we have to prove that the theorem is true for n is equal to r plus 1, right? So consider n is equal to r plus 1. That means P of union I running from 1 to r plus 1, right? AI is equal to that P of union I running from 1 to r AI union AR, right? The union of two terms. It is equal to, from using 1, what is upon P of A1 union A2 is less than or equal to P of union I running from 1 to r AI what is that AI plus P of AR, right? So since from equation 1, now equation 2, what is that? Let us suppose that equation, that the P of this is, observe that equation 2, P of union I running from 1 to r AI is less than or equal to summation. So this place of summation I running from 1 to 2 P of AI plus P of AR. So adding, sorry, this is R. Adding these two terms, summation I running from 1 to r plus 1 P of AI. So finally, therefore P of union I is equal to 1 to r plus 1 ai is less than or equal to summation I running from 1 to r plus 1 p of ai, right? Therefore the result is true for n is equal to r plus 1. The result is true for n equal to r plus 1. And by the principle of mathematical induction, the theorem is true for all positive integral values of n. Okay, this is the base theorem concept. There are two statements is there being base theorem. Okay, next class to discuss the another concept. Have a nice day. Bye.